A very good morning to all of you students of class 10. Today I am going to start part 2 of the human eye and colorful world. In the previous online class, we have learned about reflection, refraction and the total internal reflection of light. We have already learned about the image formation by mirror lenses and their uses in daily life. Now, in this part, we'll have to learn that what is a narrow beam of ordinary light is refracted by a prism, and we can see the colors bands. This phenomenon has to be other than reflection or refraction. Here you can see that the splitting of white light, which is constituent of colors or the different wavelengths by a medium, and that phenomenon is called dispersion. In this lesson or part, we will study about this phenomenon. This is a very beautiful manifestation of phenomenon in the nature also. This is the formation of rainbow. So the phenomenon is scattering of light is also there, which gives the sky its blue color and the sun red color at the time of sunrise and sunset. Here it is already given that a prism is there which consists of non-parallel refracting surfaces. It is the transparent medium bounded by the two parallel surfaces of plane surface inclined at the same angle. The prism consists of two triangle surfaces and three rectangular surfaces. Total 5 surfaces are there. The two rectangular surfaces act as a refracting surface, and the prism already has shown to trace the path of light passing through the prism. What do we need to perform the activity of diffraction? To take a white sheet of a paper and fix it on the wooden board with the help of a board pins. Put the glass prism on the paper with a triangular face touching the paper. Draw the boundary of the prism with the help of a pencil. Now fix two pins on a point on and one side of a prism and in another side of a prism. Now look at the opposite face which is shown here. You can see that the prism is there for a demonstration. Newton used the prism to demonstrate dispersion of light. That white light from a slit falls on the surfaces. The incident white light, which is split up into the components of 7 colors. These are Vibgyor, violet, indigo, blue, green, yellow, orange and red. V for violet, I for indigo, B for blue, G for green, Y for yellow, O for orange and R for red. The wavelength travelling with the different speeds actually are refracted through the different angles and are thus separated from each other. The splitting of white light into the components colors is known as dispersion. So dispersion of the white light by a glass prism is already given here. The bending of the original beam along with it is called deviation. The angle between the emergent ray and the incident ray is known as the angle of deviation. Thus the angles of deviation for the violet light and the red light is there. A light coming from the sun is termed as white light. Newton found that when the white light is allowed to fall on one side of a prism, then 7 colors are observed on the screen placed towards the opposite side of the prism, and that 7 colors are in the following order, like a Vibgyor. These colors in the particular order can be remembered as a Vibgyor. Newton concluded that white light is split into 7 colors on passing through the prism. So what we can say, the phenomenon of splitting of white light into 7 colors on passing through the prism is known as dispersion of light. The band of 7 colors obtaining on the screen when white light passes through the prism is known as a spectrum, and it is also known as visible spectrum. Hence, a spectrum of light consists 7 colors, starting from the bottom to top of a spectrum as a V, I, B, G, Y, O, R Vibgyor. It means that violet colors lies at the bottom of the spectrum and red color lies at the top of the spectrum. Thus, we can say that the white light is a mixture of 7 colors. Now, composition of white light. As we already discussed right now, that white light is a mixture of 7 colors: violet, indigo, blue, green, yellow, orange and red. Certainly, wavelength is associated to each color present in the white light. Since there are 7 colors in white light, hence the white light consists of 7 different wavelengths. This wavelength of the violet color is minimum and wavelength of red color is maximum. It means the spectrum of a wavelength increases from violet to red color. These colors having a wavelength, like violet has a 4000 to 4400 angstrom, indigo 4400 to 4600 angstrom, blue having a wavelength of 4600 to 5000 angstrom, green color has a wavelength 5000 to 5700 angstrom, yellow color has 5700 to 5900 angstrom, orange has 5900 to 6200 angstrom, and red color having 6200 to 7200 angstrom. These are the different wavelength having a rounded off to the nearest one. So 1 angstrom is equals to 10 to the power 20 meters. There is an activity given that how to show the dispersion of white light using the glass prisms. For it, we need to take a thick sheet of a cardboard and made a small hole and or narrow slit to middle. Now allow the sunlight to fall on the narrow slit. This gives a narrow beam of white light. We need to take a glass prism and allow the light from the slit to fall on one face to show the figure. Now turn the prism slowly until the light that comes out of the appear nearby screen. What do we observe? When a narrow beam of sunlight is made to fall on one face of the glass prism, then the band of the 7 colors are obtaining on the screen. It means sunlight consists of 7 colors, and the phenomenon of splitting of white light in the 7 color is known as dispersion of light. The band of 7 colors obtaining on the screen is known as spectrum. The 7 color in the spectrum from the bottom to the top of the screen are violet, indigo, blue, green, yellow, orange and red. This pattern can be memorized or remembered by an acronym that is called Vibgyor. So different colors having a different wavelengths increasing from violet to red color. Now there is some reason, so we have to study the cause of dispersion of light also. White light consists of 7 colors and each color has their own characters of a wavelength. In an air or vacuum, all color present in the white light travels with the same speed, but when the color travels in a medium other than air like water or glass, then different color travel with the different velocities. The speed of color depends directly on the wavelength. So wavelength is represented by the lambda sign. Since the wavelength of a red color is maximum and the wavelength of the violet is minimum, so the speed of red color of the prism in the prism will be maximum and the speed of violet color will be minimum in the prism. Okay, so what we can say that wavelength of the red is more than the wavelength of the violet. This means red color move faster than the violet color in the glass prism. So what we know? We know that the refractive index of the medium is given by the formula n equal to c by v. Okay, or n is directly proportional to 1 by v. Here you know that refractive index of the medium is given by n equal to c by v, means refractive index of the prism is not constant for each other. Refractive index for violet maximum and for red is minimum. Similarly, the refractive index of glass prism is different in different colors due to the reason of different colors suffering different amount of refraction from one medium to another. Okay, so whenever there is a beam of light which is passed from the glass beam, it consists of 7 colors. There is an angle of deviation is made through it. Dispersion of the sunlight through the suspended water droplet in the air produces a spectacular effect in the nature. So we will start study about these things also. If we will face prism and get separated, on again suffering from refraction on the second face of a prism. So the angle of deviation from red color is less than the angle of deviation of violet color. Red color lies at the top of the spectrum and the violet at the top of the spectrum as shown. We may conclude that the different colors of a white light travels with a different speed and this cause of dispersion of light. So what we can say? We can say 7 color recombine to give white light, and white light consists of 7 colors, so splitting up into the process of dispersion shows us 7 colors. Newton performed an experiment by taking two prisms to show that the 7 color combines together to form a white light. In this experiment, he used two prisms. Okay. So the combination of prism taken in the experiment is shown and adjoining the figure. Newton allowed the white light to fall on the first prism, and this prism dispersed the white light into 7 colors. Second prism is kept in the inverted position and the 7 colors be allowed fall to the prism. It recombines the 7 colors to give the white light and which falls the screen. It means that the white color consists of 7 colors and the prism itself does not produce colors when the white light falls on it. So the first prism is splitting the white light falling on it, hence it is known as dispersing prism. And second prism is recombining all the white light, so together it is hence known as the recombination prism. So 7 color is recombined to give white light. It is a naturally thing that rainbow is formed. Rainbow is also formed due to the dispersion of white light. Okay, so in the next class we will study about the formation of rainbow. For the day the class is over, students. Thank you and have a nice day.